Hey, also number 11, it's another one of the vertex questions. So 10, they gave us a picture we went by. So number 11, they want us to find the vertex, the axis of symmetry, determine if it's a min or max, and give that value. Then they want us to graph it. So my equation is f of x equals 2x squared plus 6x plus 2. So I'm going to start with my vertex. So remember, the vertex is a point like an ordered pair. So we got to find the x value, then the y value. So to find my x value, I'm going to do negative b over 2a. So y'all, let's figure out our letters here. A will be 2. B will be 6. And then C will be the 2 at the end. So we'll plug them into our formula here. So we got negative b, which is a 6. So that's going to make that a negative 6 now, over 2 times a, which is 2. So that's going to give me negative 6 on top, 4 on the bottom. So I can't divide 6 by 4, but I can reduce that fraction down. So I'll divide both of these by 2 since they both have a factor of 2 in them. So dividing by 2 would give me a negative 3 over 2. So we know that the x coordinate of our vertex is going to be a negative 3/2. Now, to find that y value, I find f of the negative 3/2. So we find our x value and then we plug it back into that equation they gave us. So we'll have 2 times negative 3/2 squared plus 6 times negative 3/2 plus 2. So once we figure this expression out, we can have our y value, and then the rest of this is going to be pretty quick. So this you can punch right into that calculator, just like I got it. So y'all, let's go to my calculator and we'll punch that in and see what we get. All right, so I had 2 times my fraction, which was a negative 3/2. Those parentheses and square that. Then it was plus 6 times my negative 3/2. And then at the end, it's got what, a plus 2. So I punched it in just like it looks on my paper. So now I would hit enter and I get negative 2.5. But remember, I want this to be a fraction. So I'm going to hit the math button. And then since one's highlighted for fraction, I hit enter twice and it gives me a negative 5/2. All right, so let me go back to that page. So my vertex, since I got a y value negative 5/2, my vertex would be negative 3/2, comma, negative 5/2. So you got to put the vertex exactly in as an ordered pair. So next I want the axis of symmetry. So Y'all, what is my axis of symmetry for this?
Is it -3/2?
Yeah, but remember in math lab, although you got the
X equals.
X equals, there you go. So it is actually X equals -3/2. Good job. So just remember that, y'all. Got to put that X equals on the axis of symmetry. All right. Now to determine if I got a minimum or maximum value, I'm going to look at A here. A was a +2. Anytime A is positive, when you graph it, it's going to look like a U-shaped parabola, which means I got a minimum value. So y'all, what would be my minimum value for this parabola?
2.
No, now remember, it's going to be one of them. It's going to be one of them numbers in that vertex.
Oh,
-5/2.
-5/2. There you go. So the X is always the X line of symmetry, and then the Y value is always the minimum or maximum value of this. Now, if I was going to graph this one, you got to choose the parabola tool. And y'all, the first point you got to plot is that vertex. So plot the vertex. Then plot any other point. So let me see if I can draw this real quick. So these are pretty small numbers. So I'm going to go 1, 2, 3, both ways. Now, MathLab would actually have little ticks in between this because our fractions have halves on them. So they're going to split everything into halves. So it'll have the main markers and then these little halves in between. So if I was plotting my vertex, my -3/2, if you wanted to turn that into a decimal, you'd get a -1.5. So here we go. Here's -0.5, -1, -1.5. And then the -5/2, if you turn that into a decimal, would be a -2.5. So from here, we would go down 0.51, -1.5, -2, -2.5. So that would be our vertex. Now, I'll tell you on this one, you remember y'all told me about that 2 a while ago. Although 2 is not my minimum or maximum value, this 2 right here is the y-intercept. The y-intercept is where it's crossing the y-axis at. So anytime you got a number on the end that's fairly small that you can fit on your graph, use that as your second point. So I would go up to 1, up to 2 on the y-axis, plot that point, and at that point, MathLab is going to draw your parabola for you. Now, y'all, if my y-intercept would have been a really big number, then I would have probably went to my calculator and graphed it and went to my table to get my second value. Now, let me write one more in real quick. All righty. All righty, so be careful on number 11 because it'll probably end up as fractions like mine, okay? All right, y'all. True or false? The graph h of x equals x minus 3 squared can be obtained by translating h of x equals x squared. So they're telling me x squared would be my basic graph, basically. And they're saying to get this graph, x minus 3 squared, I would translate the x squared graph, right 3 units. So y'all, true or false? We're attacking the x by subtracting 3. So is that going to move me left or right?
Right.
It is definitely going to move me right. Good job. So that means this thing is true. Good job.
Can you give me just a second to finish writing it?
And y'all get good on these because if you remember, I think number 2, 3, and 4, we're all doing this kind of stuff with the actual graphs, remember?
Okay, I got it.
Okay. So y'all, 13 is the toy rocket. So I'm going to read it and then I'll write down this equation for it that they're giving us. So 13, a toy rocket is shot vertically into the air from a launching pad 3 feet above the ground. Initial velocity of 112 feet per second. Then they say the height in feet, h, of the rocket above the ground at t seconds after launch is given by this function. So the function is h of t equals negative 16t squared plus 112t plus 3. So t is the variable which stands for time. H stands for the height. So this formula for the height of the rocket depends on the time, okay? So the first thing they want to know, after how many seconds after launch does it take to reach maximum height? How many seconds after launch does it take to reach maximum height? So that would be like finding the x variable of the vertex, okay? Now the second question, it says, what is the maximum height? And that'll be like the y coordinate of the vertex. So they want you to realize that when that rocket's shot, it'll gain altitude and then it's going to come back down and fall to the ground. So they want you to realize that this point of maximum height is the same as the vertex of a parabola. So what we want to do to get that maximum height, how long it took it to get to the maximum height, we're going to find the x coordinate by doing the negative b over 2a. So y'all look here. A is the negative 16, B is 112, and C will be the 3. So we got negative B, which is a negative 112, over 2 times A, which is a negative 16. Now think about this. When we're done, since we're talking about how much time it takes, we got to ensure we're going to get a positive answer for the time, okay? And if you notice, I got negative on top, negative on bottom. Those will cancel out, making this positive. So my negative 112 will divide by my negative 32. So y'all, let me see what that gives us. So I'm getting 3.5. So that would be 3.5, and then they'll have the seconds here for us. So y'all, my rocket shot, bam, 3.5 seconds on the x coordinate. It's at the maximum height. So now to find that maximum height, we're going to find h of 3.5. decimals, so as they say, they don't tell me to turn it into a fraction or nothing. So on this one, it'll actually take it as a decimal. So let's plug the 3.5 in for these two t's up here. We got squared plus 112 times 3.5 plus a 3. So y'all, let me plug that in our calculator here, and I'll show you. I'll just plug it in straight like it looks. So I got -16 parentheses 3.5 all right, close the parentheses and square that one. Then I got plus 112 times that 3.5. Close parentheses, and then a +3 at the end. Once we hit enter, we will have our maximum height, which is 199. So y'all come back to my page. So it took 3.5 seconds to reach the maximum height. And then the maximum height, we put into 199, and they'll have the feet to the side. Okay, so not too bad. Okay, just play with this. You'll probably get a decimal here or a whole number like 3 or 4. Plug that back into your function up there and get the actual height. All right, y'all, we're going to determine the domain. And they're giving us f of x equals the square root of 4x minus 1. All right, so remember, when you're dealing with the domain of a radical like this, the stuff on the inside of the radical has to be greater than or equal to 0. So take your 4x minus 1 and set it greater than or equal to 0. Then we'll solve this for the x, and then we'll write our answer in what they call set builder notation. All right, y'all, so to solve that, we're going to add 1 to both sides. And remember, treat this inequality like an equal sign. What you do to one side, you're going to do to the other. So bring down your 4x, has to be greater than or equal to 1. Divide both sides by 4. So that x has to be greater than or equal to 1/4. So in set builder notation, now they'll give you 4 answers to pick out of, but you want the one that looks like this. X such that x is greater than or equal to the 1/4. They'll put a less than or equal here. They'll put a not equal here. And then they'll put x such that x is any real number. Well, that's not true, because remember, this cannot be negative underneath or it causes those imaginary numbers. So we got to make sure that we use that greater than or equal on that. All right, y'all, then it looks like we had to do a little graphing. So let me get my sheet over here. So for 15, they want us to graph. And I'm going to show y'all a trick so that you can get your graph to look exactly like theirs. They want me to graph f of x equals the square root x minus 8. Now, the graphs they're using, they're going to give you 4 graphs here. But y'all, these graphs go up to 20, -20, 20 this way, -20 that way. I'm going to show you how to set your calculator for this window range so that your graph will look exactly like theirs. So to set this window range, I go on my calculator to on the top where it says window. And my Y minimum would be -20. My Y max would be a +20. Then I go down and find the X minimum, which will equal a -20, and the X max, which will be a 20. If I set this window to match this graph, then my picture will look exactly like A, B, C, or D. So first, we're going to go to Y1 and put our equation in. So y'all remember that's the square root of X minus 8. All right, so I'm just going to clear the old stuff off. I'm going to go to Y equals. Clear that off. And I'm going to put in my square root. So hit second, X squared over here, get your square root, and put in an X minus 8. Now, y'all, if you got an old calculator that does the square root and then puts a parenthesis, when you put the X minus 8, you got to close those parentheses on the old calculators, okay? All right, now look up here right by the Y equals, it says window. I'm going to hit window. So there's my X min and X max. That needs to be -20 for the minimum. And then 20 for the X max. So I guess it does the X's first, my bad. I'm going to arrow down until I hit Y minimum, which will be -20. And then enter on that, and Y max will be 20 also. Now, setting that window, when I hit the graph button, I will have exactly one of their 4 pictures. So here we go. So y'all look, that moved my graph right. So look at these 4 pictures I'm about to put up here. All right, so I'm going to zoom in just for a second. So the 4 pictures you got to choose from are A, B, C, or D. So remember, mine went to the right, sort of like D. So on that one, you would choose D. And plus, we know when we subtract 8 from the X, it moves me right anyway. So see, this graph used to be in the middle. It went right. This graph went down 8. B went left 8. And it looks like A went left 8 and turned around somehow, okay? So even if you didn't change the window, you would get something similar to that graph, okay? Now, let me show you what I'll do. If I want my window set back to normal, I'm going to go back to that calculator real quick. If you want the window set back to a 10 by 10, you hit this zoom button and go down to number 6 and hit enter. Standard means a 10 by 10 graph. So I want to hit enter. That's how it would have looked if you didn't change the window. And you can still tell it went to the right and sort of goes uphill. All right, y'all, I think they got another one for us to graph here. Let's see. So I'm going to set this back on normal.
Can you hold it right there for a second so I can know what to set my calculator as?
Mm-hmm. I'm trying to get my zoom back in. It's sort of messing me up. All right, I wanted to lock in on a real clean picture. All right, hang on one second. I don't like my writing, so let me zoom in on this real quick. All right, looks clear now. There we go. Yeah. Now, what told me to use these negative 20s and 20s was because when I looked at the graph, it had these values on it, okay? All right, also, then they had another graph. Graph g of x equals the square root 2x minus 6. Now, on this one on the graph, it goes from 5 to negative 5 on the y's. And then it looks like negative 10 to 10 on the x's. So I will go and set my, so here's your y max is right here. Your y minimum. This would be your x minimum and your x maximum. So I really don't have to change the x's since I went back to my standard window, but I will change the y values to match. So let me go to my graph now. I mean my calculator. All right, go back to y equals and clear this one out. So now I got a square root second x squared. Put in my 2x minus 6. All right, so now remember, all I got to change is my y values. So I'm going to hit window and arrow down to the y values. My y minimum was a negative 5. My y maximum was a positive 5. So now that I got them values entered, when I hit graph, we'll have the exact picture. So y'all, let me hit that graph. So notice it goes off to the right. It's a little steeper than the earlier graph. Well, we can actually tell it goes off to the right and heads uphill. So let me show you the picture you would see on that one. So that would be these pictures here. So notice this one's going left. This one moved left a little bit and went uphill. You know, that was a straight line. No way we can pick that one. But look here at D. D goes right a little bit and sort of goes uphill to match my graph. So on that one, we would pick D. So they'll give you pretty much 4 distinct pictures, okay? Now you also 15 and 16. If you want to change that window, do that. Now remember, I'm going to go back to the calculator just a second and change my window back to normal. So remember, I would hit zoom and go down to number 6 for standard. Hit enter. And then it goes back to a 10 by 10 window, okay? All right, y'all, 17 wants me to, it says, for the piecewise function, f is defined as shown. So f of x equals, now this one has 3 equations. It equals 9x for any x less than negative 2. It equals x minus 3 for negative 2 less than or equal to my x less than 4. It equals x squared for any x that is greater than or equal to the 4. So y'all, all I want to know on this problem is which equation or expression would I use to find f of a negative 2. So y'all, would y'all use the 9x expression, the x minus 3 expression, or the x squared expression to find f of -2. What y'all think? Is
X.
Which one?
X minus 3.
X minus 3. Good job. Because -2 is not less than -2. So -2 would be less than or equal to -2 would make that true. So you would definitely use the X minus 3. So we don't want to know the value it equals, just which equation you would use. There's a problem later on where we will actually find those values, but on number 17, all they want is that equation, okay? All right, y'all, so let's draw this one. They want us to identify any relative maxima or minima. So maximum values or minimum values. And then intervals of increasing and decreasing. So let's look at our graph here. Okay, so I'm trying to figure out how many points to go out. So I think we'll be good with 5. All right, so let me see. Over here at -1, 2, at -1 and 2, I got a point, and they'll write the points down for you. So that's -1, 2. Then I got a point over here at 4, -1. This point will be 4, -1. So my graph comes up on the left side, comes up to this point, then it goes down to this point from there. So let's see if I can draw this line. So it pretty much goes straight up into this point right there. And then after that, this side sort of goes uphill. So let me put what they're going to put. So first of all, they'll put the relative maximum is blank at x equals blank. And then they'll have the relative minimum is blank at x equals blank. So y'all, how about this first one? The relative maximum is blank at x equals blank. What are you putting in there? And we notice this little hump right here, that is our relative maximum right there.
-1 at x2.
Okay, you're close, but turn them around.
Okay.
So it's 3 at -1.
Oh, y'all say 2 at -1?
No, I said 3.
At
The
Oh,
relative maximum.
Where are you getting that 3 at?
I said a 3. No, 2. My bad. I'm sorry.
Okay, there you go. Ooh, okay, so it is definitely a maximum. Remember, the y values are the min and max values, like you just said. And then you said it happened at x equal to, what do you say, -1. So remember, here's my maximum value at that x. So y'all, how about this one? The relative minimum is blank at x equals blank.
-1 and 4.
-1, x equals 4. There you go. All righty. Now we want to know the interval where this is increasing. Notice I got two parts. This is going uphill from the left, and then it goes uphill from this point on. So remember, increasing, we're looking at only X values. So this graph is coming in from the left from negative infinity until it gets to this X value right here where the graph stops going uphill.
Negative one.
That's -1. Good job. And then, now they'll put this, and this point, let's see, it starts growing uphill at this point on the X's.
And 4 to infinity.
And it goes on to infinity. Good job. So y'all, that means the decrease has to be in between these points on these X values. So let's find it. All right, so decreasing is from where to where?
-1 and 4.
There you go, -1 and 4. So y'all are doing good. Stay off of that y-axis for this problem and only focus on the x's when I talk about these intervals, okay?
Mm.
Now,
I
y'all,
have
so-
a question.
Yeah,
I
I
have
hear
a
you.
question. Why did we flip the -1 and 4?
Okay, right here. Oh, right
Mhm.
here.
Down where it's like decreasing,
Because
decreasing.
yeah, right here is this part stopped going uphill at this point. So that's the point where it starts decreasing until it hits this minimum point here.
Mm-hmm.
And what I was looking at was only the X values for where it was actually going downhill.
Okay.
So I looked on this X value. Remember, this X right here was -1. This X value over here was at 4. So here we go. We go uphill, which was this one, -infinity, -1. It went downhill, which was this decrease in -1 to 4. And then from that 4, it went uphill again until it went to infinity. So your intervals, when you put them all together, will go -infinity, -1, -1, 4, 4 to infinity. That matches the whole graph now. When you put them all three there, okay?
Yeah, I get it now. Thank you.
All right, y'all. So they want me to find on this one, h of -6, h of -1, h of 1, and h of 3. Now they're giving me my function h of x equals, and y'all let me see, this one has 3 equations. It's -3x minus 11 for any x's less than -4. This one equals 1 for -4 less than or equal to x less than 1. And then it equals x plus 8 for any x's that are greater than or equal to the 1. I'm going to pull this down a little bit for us. So y'all, we're going to find h of a -6 first. So when I use the top equation, middle equation, or bottom equation?
The top equation.
Yeah, because -6 is definitely less than -4. So we're going to use the top equation and put the -6 in for the x. So we got -3 times -6 minus 11. So y'all, that's going to give me -3 times -6 is positive 18. And then 18 minus the 11 gives us a 7. What was next? H of -1. All right, h of -1, would I use the top equation, middle equation, or the bottom equation?
The middle equation.
All right, so since I'm using the middle equation, it tells me that anything in that middle equation equals 1, and that's it. So that one didn't have a variable, so that's like a constant part that goes straight across for that section. So anything from -4 up to probably what, 0 is going to equal 1. All right, now we got h of 1. So h of 1, top, middle, or bottom equation?
Bottom equation.
Yeah, because remember, the bottom one has the equals 1 part on it. So we will use the bottom one. Then that's x plus 8. So we'll put our 1 in for the x. We get 1 plus 8. Oh, and y'all, that looks like what, a 9? All right, y'all, and then last one, h of 3. Top, middle, or bottom?
Would you use the bottom one?
I would use the bottom one because that 3 is greater than or equal to 1. So let's put a 3 in for the x. We get a 3 plus 8. Oh, let's see, that's what, 11? Okay, so remember, find out which one of these ranges your value falls in and then use that equation, okay? All right, so I'll give y'all a second to write those and then we got one more to go. All right, y'all, so our last one is dealing with the difference quotient. So let me get my paper turned and my camera set. So number 20, construct and simplify the difference quotient. Now they'll give you the difference quotient, which is f of x plus h minus f of x all over h. And our function they're giving us is f of x equals a -10 x squared plus 7x plus 3. So we got a good one on this. So the first thing we got to do, we got f of x. They gave us all that. We got to find f of x plus h. So we take our function f of x and put an x plus h in for both of these x's. So we'll have -10 times x plus h squared plus 7 times x plus h, and then plus R3. All right, so I'm going to bring down my -10. The first thing I would do would be to FOIL that x plus h squared. So do y'all remember what that equals? Because this was the same for every problem you had when you had an x plus h squared.
Is it x squared plus, hold on, 2hx plus h squared?
That's it, perfect. Every time it's going to be that right there, okay? So when y'all got an x plus h squared, that's what we're going to replace it with. So see, that comes in handy saving that, okay? And then I'm just going to bring everything down, and then I'll do all my distributing on the next step. So that's our next step. Distribute the -10 through the first parentheses. We're going to distribute the 7 through the second parentheses, and then bring down our 3. All right, y'all, so here we go. -10 times x squared is a -10x squared. -10 times 2hx is a -20. hx. Negative 10 times h squared is a negative 10 h squared. Second parentheses, 7 times x is a 7x. 7 times h is a 7h. And then bring down our 3. Well, y'all, and sadly, we don't have any like terms. So all of this is our f of x plus h. So at this point, we're going to plug it into the formula. So let me write that. We're going to plug into the formula. My f of x plus h will be what we just found. Negative 10x squared minus 20hx minus 10h squared plus 7x plus 7h plus 3 minus our f of x. Well, they gave us that. It was negative 10x squared plus 7x plus 3, all of that over our h. So y'all, this is pretty long, so let's just cancel it out while we got here. We know all 3 of these are going to cancel with their counterpart in the first parentheses. You got a negative 10x squared here, but remember, a negative times a negative makes that a positive 10x squared. So your 10x squareds cancel right out. Oh, let's see, over here's a 7x, over here's a 7x. But remember, this is the positive 7x. This negative is going to make that a negative 7x. So my 7x's are going to cancel. I got to remember that negative is going to make that a negative 3. Over here, I got a positive 3. So my 3's are going to cancel out. 100%. Everything in the second parentheses will cancel from the first ones. The only things that are going to be left have to have a h in them. So we got a negative 20hx. We got a minus 10h squared. We got a plus 7h all over h. So y'all, the question of the day, what would my final answer be?
Negative 20x minus 10h plus 7.
Oh, good job. Divide everybody by 1h and simplify it like you just did and be done with this thing, okay? So I tell y'all the biggest trick on this is getting this f of x plus h. Because once you got it, all this other stuff is canceling out. These h's will be left and then divide them like you just did. So y'all, for this test, I would definitely save this right over here. X squared plus 2hx plus h squared, because 100% that'll be x plus h squared for you, okay? Oh, y'all, guess what? That was 20. So our study guide is now complete. So I did have 8-1 and 8-2 due this week, but I just don't want to mess y'all up for this next test here. Test 2 is due by Sunday night. So I want y'all to focus on doing that review until you get a good grade. Once you get a good grade on the review quiz, then knock out that test, okay? Because you can do the review as many times as you want, but you only get one chance on the actual test, okay? Also, on the bonus, I'll take that bonus all the way up to next Monday. So the bonus will be due by Monday for test 2. And I sent that to y'all's email.
I have a question about the bonus.
Yeah, I hear you.
On number 2 about the ladder,
Uh-huh.
is that like the same as we would if we're looking for the integers?
Well, okay, so do you have it with you?
Yes.
Okay, read it to me.
Says a ladder is resting against a wall. The top of the ladder touches the wall at a height of 6 feet.
Okay,
Find the length of the ladder if the length is 2 feet more than its distance from the wall.
okay.
Round to the nearest second.
So it's plus 2 feet and the distance. Okay, so over here, I got my wall. And you told me the ladder rested on the wall at a height of 6 feet. So they're talking about like this. It's resting on the wall 6 feet high. So that's going to be your 6 right there. And then it says, so it's similar, but it changes the sides on you. See, the one I gave you in the homework said it was so far from the wall. And then it said the height on the wall and the ladder were consecutive integers. So this one, they're saying it's 6 feet up on the wall. Then we don't know this distance from the wall to the ladder, but we know that the ladder was 2 feet more than this distance. So right here would be your x plus 2. To where on the one I gave you in the homework, this would have been an x plus 1 here. Okay. So now set that up as your right triangle. This would be your C, and then you can do the A and the B for those. Now remember, once y'all solve that for the X, you better add 2 to get that ladder, because the ladder is this side, which was x plus 2, okay? So that should help you out on that, hopefully.
Okay, thank you.
All righty. All right, so I'm gonna stop sharing this screen. So y'all, let me ask you, do you have any questions?
I don't have any questions, but on my notes, I actually got kicked out on number 9, and I was wondering if you still had that so I could kind of look over it.
Let me see. Oh, from the other day?
Yeah, from Monday.
Yeah, let me see. Let me see if I got that 9 down in here. Okay, 9 was another one similar to that. So let me put this down and let me share this real quick. So that was number 9 from the other day. And it was doing that ladder problem too. And this was actually like the one in the homework where you had the x plus 1 side, the x, and then they gave you the distance from the wall on that one.
Okay, can I copy that real quick?
Oh yeah, I'm letting you.
Okay, thank you.
All righty. All righty, y'all, don't see nothing in my chat. So any more questions? All righty, so remember, test 2 is due by Sunday night at midnight. If you have any issues practicing for it or anything, email me, because I will answer them emails pretty quick for y'all, okay? Well, I'm going to quit our recording.